Okay, we've had a little bit of practice of taking the Laplace transform of a step function times another function. Now we're going to work on going back the other way. And when we're doing this, we're going to find it is easier for us to use the format of formula B here. A and B are just really, really closely related. We can get, later in the videos, we're going to prove B. We can get A from B just by defining G of t as f of t minus a. Then if we rewrite this, then we have ua of t times g of t is equal to e to the negative as times the Laplace transform of g of t plus a. So really, this is just a rewriting. We use B because it's for this inverse Laplace transform because it's just a slightly easier format. So if we have the inverse Laplace transform of e to the negative as times some f of s, Laplace transform of little f of t, this is going to be equal to ua of t times that inverse Laplace transform of t minus a. Okay, so we're going to first find the inverse Laplace transform of f of s, which is f of t. Then we're going to shift f right by a. And multiply by the step function. All right, and we're going to check this out with two examples. Two basic examples before we get to something a little bit more complicated. Okay. So first off, we're going to find the inverse Laplace transform of e to the negative 2s over s plus 1. So I'm just going to rewrite this so that we see that exponential just off on the side, because we really are going to kind of hold it. It definitely influences our results. But we are going to just hold on to it. Our formula, again, e to the negative as times f of s is ua of t times f of t minus a. So in our example here, a equals 2 and f of s equals 1 over s plus 1. Its inverse Laplace transform, f of t, is e to the negative t. And so our formula says that this is going to be equal to u2 of t, f of t minus 2. And so that means every time I see a t in this e to the negative t, I'm going to just write a t minus 2 using parentheses. Okay. So this gives us u2 of t, e to the negative 2 minus t. Let's take a look at another example. Okay, so here we have the inverse Laplace transform of e to the negative 5s times 2s plus 3 over s squared plus 49. Okay, we're going to use the same formula. So here our a is equal to 5. Our f of s, whose inverse Laplace transform we're going to be trying to find, is 2s plus 3 over s squared plus 49. Okay, we can always work this out on the side if we like to. 2s plus 3 over s squared plus 49. We should break this up, and we can use our sheet to help us along the way. So this is going to be 2 times the inverse Laplace transform of s over s squared plus 49. So that gives us a cosine term. All right, and we also have a sine term. Our k squared here is 49. So for the sine term, we needed just a single k up top. So that's going to be 7. We multiplied in by 7. We need to divide by 7 as well to balance it out so that we aren't actually changing the value of our expression. Okay. And so this gives us 2 times cosine of 7t plus 3/7 sine of 7t. Okay, and so applying our formula that the inverse Laplace transform of e to the negative as times f of s is going to be first our our step function u5 of t. And then every time we see t in this guy, which is f of t, little f of t, we're going to be writing parentheses t minus 5 because we want to shift it to the right by 5. So we get 2 cosine of 7 times t minus 5 plus 3/7 sine of 7 times t minus 5. Okay, we should just be careful about parentheses. Oops. And here we are. Also, not too bad.